Okay, so in this video, we are going to discuss what's known as kinematic synthesis. Okay, so particularly what we are going to focus is kinematic synthesis of a 4-bar mechanism. Okay, and to be specific, the 4R, all the links are connected through a revolute joint. So that's what we are going to do. Okay, so for what requirement we are going to perform this kinematic synthesis? So in that regard, I have chosen a problem where the 4R mechanism is going to be a crank rocker mechanism. Okay, so crank rocker mechanism. Okay, so what's crank rocker mechanism? Say you have a 4R mechanism where this is like a crank which will have a complete rotation, and then there will be a rocker which will not have a complete rotation, it will just oscillate. Okay, where these two things are being connected by a connecting rod. Okay, so now what's the requirement? The requirement is uh, when this crank is having a complete rotation, this rocker will oscillate. Okay, say it's oscillating between this position to this position, and the requirement is, so the it's just changing the orientation, and the change of the orientation we can represent through the angle theta, and this angle should be some theta. Let's say that theta should be 70 degree. Okay, maybe instead of theta I'll call that as alpha. Okay, so my alpha has to be 70 degree. So in that case, what's L1 and what's L2? Similarly, what's L3 and also L4? So this is our kinematic synthesis. So once I know this L1, L2, L3, L4, then I can construct the mechanism. Okay, so this is what I need to identify for this requirement. Okay, so to do the synthesis, what we're going to use is the Geogebra. Okay, so in Geogebra, first what I'm going to do is I'm going to draw a line where one line represents one extreme of the configuration and the other line represents the other extreme of the configuration. Okay, so let me draw those two lines. In order to draw those two lines, I'm going to first create a point. Let me create a point. So one point is going to be the origin, the other point is going to be, let me assume, say B. Okay, and what I'm going to do is I'm going to create a line between those 2 points, not a line segment but a line. Okay, okay, now I'm going to create one more point. Okay, and that point is, okay, but before creating that point I need to introduce alpha. So let me call that as ALP, which is 70. Okay, and let me, okay, so now C, which is equal to um, the distance between A and B. Okay, so that's going to be my L4. So I'm gonna fix L4. I'm just going to assume L4. Okay, so the L4 is nothing but the distance between A and B. So now let me call, even before that, let me call L4, which is equal to distance between 2 points, point A and B. Okay, right. So now if you notice, if I change this point, okay, my L4 is going to change. Okay, fine. Now I'm going to so instead of calling this point as B, what I'm going to do, I'm going to call this point, let me call this point, let me not call this point, let me do one thing, I'm going to call this point O4. Okay, so you'll get to know why I have called this point O4. And this point B, I'm going to call this as B1. Okay, I'm going to call this as B1, and then I'm going to introduce a point B2, which is since O4 is the origin, I can easily define that point in the following manner. So L4 into cos D, is it cos D of alpha comma sin D of alpha. Okay, I think this is not working. Where alpha is in degrees, but I should give it in radians, so into pi divided by 180, and similarly into pi divided by 180. Okay, so now that's my point B2. Okay, and what I'm going to do, I'm going to draw one more line, okay, which connects, not line segment, line which connects O4 and B2. Okay, so these are not the links, these are some reference lines. Therefore what I'm going to do, I'm going to not going to put those lines as a solid line. So I'll go to the settings, and then in the tail I'm going to choose that as like a such line. Okay, right, so if you see, it's just dot dot dot, and I will do the same thing for the other line as well. So in the style, I'm going to put this one. Okay, fine. Now that's my O4. So let me give my names for these points. So what I'm going to have is, this point is O2, and that point is A, and that point is B, and this point is O4. So this point, okay, so which is when this link goes to this extreme, then this point I'm going to call that as B1, and in the other extreme I'm going to call that point as B2. Okay, and you know that this is between O2 and O4 is L1, and this link is L2, and this is L3, and this is L4. Okay, so therefore this distance I have called between O4 and B1 I have called as L4. Okay, now after I have constructed this, what I should do, I'm going to draw a line which is going to pass through B1 and B2. Let me draw the line. So let me ups. Okay, so these are the two extreme points. Okay, and then what I'm going to do is I'm just going to make a point on this line. Maybe even before that I will do one thing. I will just change the style. Okay, and then I'm going to create a point in this line. So right now randomly I'm going to put, okay, and then I'm going to put another point. Okay, so I'm just going to put another point. No, let me delete this point. Okay, so now what I'm going to do, so this distance I'm gonna call, let me measure that distance first. So let me call that as some k1, which is equal to distance of b1 comma b2. Okay, fine. Now what I'm going to do, I'm going to have a point in this line, okay, with the distance of half of this one along this line. Okay, so let me see how to do that. Let me construct a line, sorry, let me construct a circle. Okay, so that's how I can do that. So let me construct a circle, circle with center and radius. So A is going to be the center, the radius is going to be k1 by 2. Okay, the radius is going to be k1 by 2. right. And now the intersection of these two points. Okay, fine. Mm, and so basically, then this is actually, let me give the proper name. So that's not A, that's actually O2. Okay, so that's O2, and this is not B, this is A1. Yeah, so that's A1. Okay, so now I'm gonna define L3, sorry, L3, which is actually the distance between A1 and B1. Okay, so A1 comma B1 is the L3 distance. Okay, okay, and I have A1. I also need to identify what's A2. By the way, what do I mean by A1 and A2? Let me go to this picture once again. uh, See, when this point is over here, okay, so when this link is over here, okay, at that time it will be like a straight line. It's been connected like a straight line, and this A is somewhere here, and I'm calling that point as A1. Okay, and the distance between A1 and B1, I'm going to call that as L3. Okay, and then does that mean I know so then the another so with this distance, let me draw one more thing, so which connects this point to the another point, which is the other extreme, right? So okay, so that will be A2. Okay, fine. So that's what A1 and A2 are. Let me go to this picture again. Now so I kinda identified one second. Yeah, I kinda identified what is L3. Maybe this distance. So if this distance is L3, and with the same distance, let me draw one more circle. Yeah, with B2 as a center, and okay, and L3 as a radius, right? So B2 as a center and L3 as a radius. Okay, okay, and that's getting connected over there. Okay, yeah, right. So which means that point will be L2. In that case I don't require this, let me delete it. So what will be my L2? My L2 is going to be equal to distance of O2 comma A1. Okay, O2 comma A1 is L2, and L1 is equal to distance of O2 comma O4. Okay, so I have what is L1, L2, L3 and also L4. Okay, so now let me construct the mechanism. So in order to construct the mechanism, let me also hide this circle. Okay, now I'm going to introduce something called theta. Okay, let me just now assume 0. Later I will change that into a slider, and now I'm going to define what's A, which is O2 plus L2 of L2 into cos TH into pi divided by 180 comma sin TH into pi divided by 180. Okay, and that's my A. Okay, and what's my B? So for B, what I need to do is I need to draw two circles and I need to do the intersection. So one circle is going to be from with A as a center, and L3 as the radius. Okay, and another circle with O4 as a center and L4 as a radius. Okay, and they intersect at this point. Okay, and that intersecting point is what I'm gonna call as B. Yeah, so let me hide the unwanted things, this circle, and this circle. Okay, and maybe I could also remove this line. Where is that line? Between B1 and B2, right? Right, so let me use the line segment now. O2 A, and then from A to B, and then from B to O4. So that's our linkage. Now let's see if I give, so this theta, so introduce, create slider, yeah, where in the settings let me change, the minimum is 0 and the maximum is 360. Okay, and should not oscillate, it will keep on increasing. Okay, right, and if I run, it's going between two extreme positions, right? Yeah, even I can hide this A1. What else I can hide? Right. Okay, so that's a very simple kinematic synthesis. We have easily synthesized this L1, L2, L3, L4 for our requirement. And is this a unique solution? The answer is no. Okay, so what you could do is you could change some of the distances, but still you can make sure that this requirement has got satisfied. For example, what you could do is you could let me make sure that I have chosen the move. Okay, and say for example, if I change my this b1 point, okay, what will happen is the link length, okay, the link length L4 has got increased. Okay, maybe it is somewhere here. The link length L4 has got increased. Accordingly, the other link length also has got changed. Okay, maybe you could notice L3, L2, L1. Okay, those things also has got changed. So you could change the link lengths by adjusting this b1 point. The other thing you could do is you could also change the link lengths by moving this point O2. Okay, say for example, let me move this point O2. So even then I'm able to change the link lengths. Okay, maybe not the link length of uh, L4, but the other link lengths, right? So that's the simplest kinematic synthesis we have done. Okay, and if you notice, there is something called quick return ratio. So just check what is the quick return ratio, whether it's 1 or whether it's more than 1. Okay, uh, so fine. So that's our simplest quick return mechanism. Maybe in the later video we'll see the other way of doing the kinematic synthesis for some other requirements. Thank you.